Hello, everyone. Welcome back. And today we're gonna keep going with chapter 6 with circular functions, and we're gonna do the tangent function. So probably you guys already know the tan theta equal to sine over cosine. Please make sure cosine theta are not equal to 0. And we have a tables, and here is a special angles for the tangent. And you can see the undefined, which means when cosine negative pi on 2 that equal to 0, and pi on 2 equal to 0, and 3 pi on 2 equal to 0, and 5 pi on 2 equal to 0. So we can say the once cosine equal to 0, that's all undefined. And that's why when we graphing the tangent, we have the asymptote. So the asymptote means the theta equal to 90 degrees, negative 90 degrees, and to 70 degrees, and then 540 degrees, and so on. So, and the graph actually, the periods are equal to pi. So how are we going to calculate the periods? So we need to know our periods with, for example, if we had an n, so that equal to pi over n. So that's how you calculate the how to calculate your periods. So we can say between 0 to pi, and then also we can say between pi on 2 to 3 pi on 2, that's a pi, and then that's the periods in between. And region for the tan theta always equal to the real number. Any number can be fine. And we have the vertical asymptote, so which is when the theta equal to 2k plus 1 pi over 2, so which is like, for example, we have pi on 2, negative pi on k can be any number, positive and negative, whole number. So, and intersection will be theta equal to k pi. So hopefully that makes sense. And so graphing the a to 10 and t, so here is the details. I want you guys to make sure to put this one to your band reference, and that not gonna be and also the transformation and dilation part, you guys are able to do as well. Okay, let's sketching the first one. I'm probably gonna do B um, when we back on the circular function in class. So I'm gonna do that in class. So let's start with 3 tan 2x. So first thing first, let's try with the periods. So that equal to pi over n equal to pi over 2. So which is your periods is pi over 2. And asymptote, so that equal to x equals 2k plus 1 pi over n over 2. So which is sorry, over 4, and which is any numbers, and k can be any numbers like that. And your axis intercept will be x equal to k pi over 2. So this is why we need to know this, and that. Okay, so be aware. And then what we're gonna do is we can sketching our graph with x and y values. So yep, perfect. Yeah, so because it's negative pi to pi, so we can just do a little bit like this way. And why? First thing first, we need to find our asymptote. So -3 pi over 4. So that's the asymptote. And this is negative pi. So we go in here. Yep. And so this is negative pi over 4. That's another asymptote. So always gonna be a pi over 4. So there you go. So this is half pi. And we go from here to here. Okay, perfect. And we keep going with so this is pi over 4. So we can go from here and cross 0 and going up like that. Next one will be 3 pi over 4. So 3 pi over 4, that's your asymptote. Once you find asymptote, easy to find the intersect points, and this is pi over 2. Okay, and then last one will be pi, so we'll be here. Yeah, that's it. Okay, actually, yeah, leave that one, x. Yeah, perfect. So this is the graph we need to know from the tangent. Hopefully that makes sense. And now we're gonna go to something with transformation part. Sketching the graph with y equal to 3 tan 2x minus pi on 3. And your x is between pi on 6 to 13 pi on 6. Okay, first thing first, we need to write the transformation. So dilation of factor 3 from x-axis, and dilation of factor half from y-axis. And and translation of pi on 6. So pi on 6 units. Y is pi on 6 because 2x minus pi on 6. Okay, just bear with me. So that's can go here. Units in positive direction of x-axis. Yep, and that's it. Once we know this, and we're gonna find the periods. Period equal to pi on 2, and asymptote equal to x equal to 2k plus 1 pi over 2n. 2n will be 4. And also because you plus pi on 6, okay? So that's it. And axis intercept. So we will start with x equal to k pi over 2 plus pi on 6. Equal to 3k plus 1 pi over 6. Okay. It's not bad. Now equal to 12 maybe. We try to just make as one fraction. Yeah. Okay, now what we do is we can sketching the graph. So it's pi on 6 to 13 pi on 6, which is we can start with here. So pi on 6, clearly that's the intersection point. Yep, so pi on 6, intersection point. So pi on 6, and so 5 pi on 12, so which means you had that. And 2 pi on 3, 2 pi on 3. You finish on 11 pi. So 11 pi on 12 is your asymptote. So your graph value looks like this. Good job. And the next one, which is 7 pi on 6. And your asymptote become to 17 pi on 12. So you just keep adding the half pi. So there you go. Because your period is half pi, so that's why you can just keep adding. That's it. And then the last one, maybe 23. So 5 pi on 3, 5 pi on 3, and to 23 over 12 pi. So there you go. So 23 pi over 12. Yeah. And one more actually. So because it's 13 pi over 2 over 6, so we just keep going that way. So 13 pi over 6 is your endpoint. So there you go. Good job. Perfect. Not bad. Next question will be solved for the equation, and I want you guys to know how to do this. So we just leave the time to x. Now equal to 3, root 3 over 3, or equal to 1 over root 3. That's the same way. 2x equal to pi on 6. Remember the special angle tables, please make sure using that table, okay? Or 19 pi on 6, okay? So because pi and 2x is between 0 to 4 pi, okay? So x are equal to pi on 12, 7 pi on 12, 13 pi on 12, and 19 pi on 12. There you go. It's pretty quick to solve these kind of questions. And a little bit trickier question I want to do by during the class, so make sure you guys understand this. And the sketching graph, this one, I'm gonna use it as example to do in the class. This is the hardest one, and also we can do to using the CAS calculator. All right, perfect. This is today's lesson, and I'll let you guys know during the class. Let me have a look, and then if you have any question, please email me, and I'll see you guys in class.